In this lesson you will learn about triangles. And the first thing about triangles is that when you classify triangles by angles, you have 4 different types of classifications. When all of the angles in a triangle are less than 90 degrees, then the triangle is acute. When you have one angle that's equal to 90 degrees, then the triangle is right. And this box in the corner represents a 90-degree angle. When only one of the angles in a triangle is greater than 90, then it's an obtuse triangle. And when all of the angles are equal to 60 degrees, it's called equiangular. And an equiangular triangle is sometimes just represented with single arcs to show that all of the angles are the same. To classify a triangle by sides, there are 3 types. A scalene triangle is when you have 3 sides that are different, and the different number of dashes through each side means that the 3 sides are different. In an isosceles triangle, it's a triangle with at least 2 congruent sides, but an equilateral triangle is when all 3 sides are congruent. If all 3 sides are congruent, then you also have 3 angles that are equal to each other. So if the sides are equal, then the angles are equal, so an equilateral triangle is also equiangular. In this triangle, the type of isosceles triangle where you only have 2 equal sides, the 2 sides that are equal are called the legs. And across from the legs, you have 2 angles that are equal that are called the base angles. The angle that's different than the base angles is called the vertex angle. And the side that's different from the legs is called the base. So one very important rule for all triangles is that all of the interior angles add up to 180 degrees. So if we were to classify this first triangle by angles and sides, I first notice that all of the degree measures are different and all of them are less than 90 degrees. So since they're all less than 90 degrees, that makes this triangle acute. And since all of the angles are different, that means that all of the sides are different, so it's also scalene. For the second triangle, we have one angle that's greater than 90, so right away it's an obtuse triangle. And then we have 2 angles that are the same. So if you have 2 angles that are the same, they're your base angles, and the sides that are across from those base angles are called your legs, and that makes this triangle isosceles. In the next triangle, we have a 90-degree angle, so therefore it's a right triangle. And we also have 2 45-degree angles. So since these 2 angles are the same, that makes these 2 sides the same, so these are the legs of an isosceles triangle. For this last one, we have 3 angles that are equal to 60 degrees. So when all of the angles are the same, it's an equiangular triangle. So if all of the angles are equal, then all of the sides are equal. So not only is it equiangular, but it's also equilateral. And the definition of an isosceles triangle is when at least two sides are equal. So not only is this triangle equilateral, but it's also isosceles. So this one has three classifications. So the directions are to find the missing angles of the triangle and then classify the triangle by its angles and sides. So I have three angles, and I know that all of the angles of a triangle are equal to 180 degrees. So I start by taking x plus 3x plus 32, setting up an equation, and setting it equal to 180 degrees. Once I have my equation set up, I combine my like terms of x and 3x, which is 4x, and to solve for x, my next step is to subtract 32 from both sides so that I get 4x is equal to 148. Divide both sides by 4, and I get x is equal to 37. So with x equal to 37, I know that this angle is 37 degrees. I already know this bottom angle on the left is 32 degrees, so that just leaves 3x. So on the side, 3x degrees is equal to 3 times 37, and 3 times 37 is equal to 111 degrees. So if I were to classify this triangle by angles, I notice that I have one angle that's greater than 90 degrees. So it's an obtuse triangle. The other thing I notice is that all of my angles are different. So if all of the angles are different, that means that all of the sides are different. And if all of the sides are different, it's a scalene triangle. So this triangle is obtuse and scalene, and the missing angles are 32 degrees, 37 degrees, and 111 degrees. For number 2, we have an isosceles triangle because we have these two markings through two of the sides telling us that they're equal. So that means that this angle is the other base angle, and it's also equal to 2x plus 10. So to set this up, I always start by finding x first, and I take all three angles, x plus 2x plus 10 plus 2x plus 10, and set the equation equal to 180. Whenever you're finding x and the expressions represent angles, you always set it equal to 180 degrees. And then you start to solve for x by combining and the first step in solving for x is to combine your like terms. So we have x plus 2x plus 2x is 5x plus 20 equals 180, and then subtract 20 from both sides so that we get 5x is equal to 160. Divide both sides by 5, and we get x is equal to 32. So this vertex angle is equal to 32 degrees, and then to find each of the base angles, they're both equal to 2x plus 10, so we take 2x plus 10 and substitute 32 in for x, so that we get 64 plus 10, which is 74. So both base angles are equal to 74 degrees. So to classify this triangle by its angles, we have three angles that are all less than 90 degrees. So that means by angles, this triangle is acute. By sides, we knew from the beginning that it was isosceles because we had the markings between two sides. So it's an isosceles triangle. And the three angles are 32 degrees and then two base angles of 74 degrees each. For number 3, we have another isosceles triangle, and the legs are just on different sides, but it doesn't change the fact that we have two base angles, which would be these two angles. So the base angles are always across from the legs. So that means this other red angle is 3x For number 3, we have two sides that both have dashes through it, so that means that we have another isosceles triangle, but the base angles are across from the sides that are marked as being equal. So this other angle on top that's not labeled is the other base angle, and it's equal to 3x minus 12. So once you have all of your angles labeled, you just start by writing your equation, 3x minus 12 plus 3x minus 12 plus 2x, and set the equation equal to 180 because the expressions represent angles. And I combine my like terms, and I get 8x minus 24 equals 180. I add 24 to both sides so that I get 8x is equal to 204. And when I divide both sides by 8, I get a decimal, and I get x is equal to 25.5. So starting with the vertex angle of 2x, I'll do that work on the side. 2x is equal to 2 times 25.5, and 2 times 25.5 is equal to 51 degrees. So my vertex angle is 51 degrees, and then my base angles are both represented as 3x minus 12, so I take 3 times 25.5 and then subtract 12. 3 times 25.5 is 76.5, and then minus 12 is 64.5. So each of my base angles are 64.5, so I have 3 degree measures of 64.5, 64.5, and 51 degrees, which means that our triangle is acute because all of them are less than 90 degrees. Since 2 of those angles are equal, that means 2 of the sides are equal, so it's an isosceles triangle as well. For number 4, the ratio of the angle measures of a triangle is 8 to 13 to 15. So before I read on, I'm just going to draw a triangle, and because we're given angles that represent a ratio, I'm just going to add x's next to each of those numbers and write the angles as 8x, 13x, and 15x. You can put the 8x and the 13x and 15x in any angle you'd like, as long as you include the x. And now that I have my 3 angles, I set up my equation, 8x plus 13x plus 15x, and set it equal to 180 degrees. These are all like terms. And I get 36x is equal to 180. And if I divide both sides by 36, I get x is equal to 5. So that means 8x is equal to 40 degrees. 15x, 15 times 5, is equal to 75 degrees. And then 13x, 13 times 5, is 65 degrees. So our three angles are 65, 40, and 75. All of the angles are less than 90, so it's an acute triangle. And since they're all different, that means all of the sides are different, so it's also scalene. So now we're going to look at triangles that give us the perimeter. And now these expressions represent sides. So we'll no longer be using the 180 rule because the 180 rule only applies to angles. So we have three sides with expressions of 3x plus 2, 2x minus 1, and 9x. Perimeter means we take those three sides, add them together, and set it equal to 183. And we solve for x. And we have 14x plus 1 equals 183. And then subtract 1 from both sides so that we get 14x is equal to 182. Divide both sides by 14, and x is equal to 13. So all we're asked to do is find the missing sides of the triangle. So with x equal to 13, to find 9x, I take 9 times 13, which is equal to 117. And then for 2x minus 1, I take 2x minus 1 and substitute 13 in for x. 2 times 13 is 26, minus 1 is 25. And then for 3x plus 2, I take 3 times 13 plus 2, which is 39 plus 2, and I get 41. So the missing sides are 41 feet, 25 feet, and 117 feet. For number 6, we have an isosceles triangle because two of the sides are marked as being equal, so we know that the other leg is equal to 3x minus 1. So knowing that the perimeter is 11, we would take 3x minus 1 plus 3x minus 1 and add it to 1/2 x, and then set all three sides equal to the total perimeter of 11. So if I add my x's together and my negative 1's together, 3x and 3x is 6x, plus 1/2 x is 6.5 x. So I'll write it like this for now, and I'll change it later. And then negative 1 minus 1 is negative 2. And to solve for x, I start by adding 2 to both sides. So that's 6.5 x is equal to 13. And before I divide by 6.5, I'd like to change this to And before I divide by 6.5, I'd like to change 6½ to an improper fraction of 13 over 2 and set 13 over 2x equal to 13. And now I just multiply by the reciprocal of 2 over 13 so that the 13s and the 2's cancel on the left. The 13's cancel on the right, so x is just equal to 2. So if I take 2, substitute it in for x, 1/2 of 2 is just 1. And then for 3x minus 1, the 2 legs, we'll take 3 times 2 minus 1 and get 6 minus 1, which is 5. So both legs are equal to 5. And so our three sides are 5 meters, 5 meters, and 1 meter. For number 7, the ratio of the sides of a triangle is 8 to 15 to 17, and the perimeter is 80. So I'm just going to draw a triangle. And whenever you're dealing with a ratio, you always add x to the numbers that are in the ratio. So I'm going to say that the sides are 8x, 15x, and 17x. And if I know that my perimeter is equal to 80, that's the start of an equation, which is 15x plus 8x plus 17x equals 80. If I add my x's together, 15x plus 8x is 23x, plus 17x is 40x, and then dividing both sides by 40 gives me x equals 2. So I know that 17x, or 17 times 2, is 34, 15 times 2 is 30, and 8 times 2 is 16. So the first part of the directions are to find the length of each side, which are 16, 30, and 34, and then to classify the triangle by its angles and sides. Well, since all of the sides are different, we know that it's going to be a scalene triangle. But to classify it by angles, we know it's not equiangular because all of the sides are different, and we know that it can't be So to classify this by angles, we want to check to see if the Pythagorean theorem works. And the Pythagorean theorem is a squared plus b squared equals c squared. So if we're given sides of 16, 30, and 34, we would have to make c equal to 34 because it's the longest, and then we could make the 16a or the 30a. I'll just go in order. And if we substitute the numbers in, (16) squared is 256, 30 squared is 900, 34 squared is 1156, and if we add 256 and 900, we get 1156. So since the two sides match, we know that this triangle is also a right triangle. For number 8, we have triangle ABC that has coordinates of A, 1, -1, so right 1, down 1 is right here, and then B, -2, 1 is left 2, up 1, and then C, -4, 2 is left 4, down 2. And if I connect the points, I have my triangle. and we want to find the length of each side and then classify it by its sides. So when I'm given coordinates, the way I find the length of each side is to use the distance formula. And just to refresh with the distance formula, it's x2 minus x1 squared plus y2 minus y1 squared. And starting with segment AB, if we have point A is 1, negative 1, and B is negative 2, 1, I'll make A x1, y1, B x2, y2, and I take these values and substitute them in the distance formula. So x2 is negative 2 minus x1 is 1 squared plus 1 minus negative 1 is y2 minus y1 squared. Negative 2 minus 1 is negative 3 squared. And then 1 minus negative 1 is positive 2 squared. So that we get the square root of 9 plus 4, which is equal to the square root of 13. So segment AB is equal to the square root of 13. Next, we'll find BC. And BC has coordinates negative 2, 1. C is negative 4, negative 2. And now we'll make B x1, y1. And C is x2, y2. Substitute the values into the distance formula. So we have negative 4 minus negative 2 squared plus negative 2 minus 1 squared is equal to negative 4 minus negative 2 is now just negative 2 squared, and negative 2 minus 1 is negative 3 squared, and we're getting the same numbers as before, just reversed, but it still gives us the square root of 13, so BC is the square root of 13. So far we know that this triangle is isosceles. To check if it's equilateral, we have to find the length of AC. So I just repeat the process one last time. A is 1, negative 1, and C is negative 4, negative 2. So 1, negative 1 is x1, y1. Negative 4, negative 2 is x2, y2. And I use the distance formula. So I have negative 4 minus 1 squared plus negative 2 minus negative 1 squared. I'm just substituting the points into the distance formula. Negative 4 minus 1 is negative 5. And negative 2 minus negative 1 is negative 1. And so we have the square root of 25 plus 1, which is the square root of 26. So since all three sides are not the same, we know it's not equilateral, but we do have two sides that are the same, so it's isosceles. So the length of each side, I'll just lower this a bit and put the answer, are square root of 13, square root of 13, the square root of 26, and we only have to classify it by its sides, and since two of them are equal, it's an isosceles triangle. And for number 9, we have the length of the first side of a triangle is 7 more than twice the second. So let's start with the first side, the second side, and we know there'll be a third side. And it's saying that the length of the first is 7 more than twice the second. So 7 more than twice the second translates to 7 plus 2x. And since we're describing the first using the second is just x. The next sentence says that the length of the third side is 4 less than 3 times the second. So when you have less than, it's minus, but it comes at the end. So 4 less than means minus 4, and then 3 times the second is 3x. We know that the perimeter is 39 centimeters. So I take my 3 sides of 7 plus 2x plus x plus 3x minus 4 and set it equal to 39 and solve for x. And I always start by combining my like terms. So I have 6x, 7 minus 4 is 3, and then I subtract 3 from both sides, so that's 6x is equal to 36, and then divide both sides by 6, so that x is equal to 6. So now if I draw my triangle, my second side we know is equal to x, so I'm just going to label one of these sides as 6. And then 3x minus 4 is 3 times 6 minus 4, which is 14. And then 7 plus 2x is 7 plus 2 times 6, which is 19. So we have 6, 14, and 19. So the length of each side is 19 centimeters, 14 centimeters, and 6 centimeters. And the last problem, we have an isosceles triangle where the measure of the vertex angle is 5 more than 3 times the measure of each base angle. So in an isosceles triangle, we have a vertex angle and 2 base angles. So if I draw an isosceles triangle, this is our vertex angle. If we make these two sides equal, then this is one base angle, and this is the other base angle. And the base angles in an isosceles triangle are always equal. So we're told that the vertex angle is 5 more than 3 times the measure of each base angle. So 5 more than 3 times means 5 plus 3x. So we're describing the vertex using the base, so that means the base is equal to x. So once I have my angles labeled, 5 plus 3x, both bases are equal to x, I know that the degrees in a triangle equal 180 degrees. So I have 5 plus 3x plus x plus another x for the other base angle. Set it equal to 180 degrees. Combine my like terms. And solve for x. And last step in solving for x is to divide by 5, and I get x is equal to 35. So if x is equal to 35, then each base angle is 35 degrees, and the vertex angle is 5 plus 3 times 35, which is 110. So the measure of the three angles are 110 degrees, 235 degrees, so we have 35, 35, and 110. And since we have one of those angles that's greater than 90 degrees, that makes the triangle obtuse.